The most famous question about aliens may be based on something Fermi never actually claimed. That statement alone should make you uncomfortable. For decades, the Fermi Paradox has been the lodestar of anyone who has ever looked up at the night sky and wondered why it stays so stubbornly, maddeningly silent. It is the foundational puzzle of astrobiology, the intellectual hand grenade tossed into the middle of every conference on extraterrestrial intelligence. It is a question so elegant in its simplicity that it seems to have been carved into the stone of scientific inquiry itself. If the universe is so vast and so old, and if the ingredients for life are supposedly everywhere, then where is everybody? That question, delivered with a shrug and a flash of mid-century brilliance, is supposed to have detonated the entire field of SETI into existence. Except it didn't happen. Not the way you think. The story we tell ourselves about the Fermi Paradox is a myth we constructed long after the fact. A narrative stitched together from second-hand recollections and academic self-interest. And that myth, however compelling, might be the very reason we have been asking the wrong question all along. The year is 1950. The place is the Los Alamos National Laboratory, a sprawl of concrete and secrecy in the New Mexico desert, where the ghosts of the Manhattan Project still linger in the corridors. Enrico Fermi, the Italian physicist who helped usher in the nuclear age, is walking to lunch with a few colleagues, Emil Konopinski, Edward Teller, and Herbert York. The conversation, as it often did among men who had just split the atom, drifts to the latest headlines. A cartoon in the New Yorker has just appeared, poking fun at the spate of flying saucer sightings that were then gripping the American public. Garbage men in Portland, airline pilots over Kentucky, everyone seemed to be seeing discs in the sky. The cartoon, by Alan Dunn, showed a flying saucer landing in a field and a man in a trench coat urgently pointing toward a trash can. A visual gag about the government's habit of scooping up debris. Fermi, ever the iconoclast, uses this as a springboard. As the group settles into the cafeteria, he throws out a series of rapid-fire calculations on the back of a napkin, or so the legend goes. Given the age of the universe, the number of stars, and the probabilistic likelihood of planets, he roughly estimates that extraterrestrial civilizations should have been here millions of times over. They should be everywhere. They should be us. And then, with a characteristic twinkle of mischief, he looks up from his arithmetic and simply asks, "But where are they?" It is the perfect origin story. A simple question from a genius, spontaneous and profound, that cuts through all the astrophysical jargon to reveal a cosmic loneliness so acute it borders on terror. The only problem is that no one in that room, not Teller, not York, not Konopinski, ever wrote it down. There is no transcript. There is no memo. There is no published paper, no journal entry, no letter to a colleague where Fermi commits this thought to paper. Teller, who lived a long and verbose life, later recounted the lunch in his autobiography. But even his version is fuzzy on the phrasing. York, in his memoir, didn't mention the question at all. Konopinski, whose memory is the most frequently cited source, only remembered Fermi positing that the saucer sightings couldn't be alien because the Earth would have been colonized long ago. A subtle but crucial difference. Fermi never said, "Where is everybody?" in the way we now recite it. He didn't make it a paradox. He didn't give it a name. He didn't launch a research program. He ate his lunch, made an offhand observation, and presumably went back to working on the hydrogen bomb. For all intents and purposes, the question that would define a generation's search for meaning in the cosmos was a casual, unrecorded remark that lasted less than 30 seconds. And then, it was over. So, how does a lunchroom aside become the cornerstone of a scientific discipline? The answer lies not in Fermi's brilliance, but in the agendas of the men who came after him, particularly the astrophysicist Michael Hart and the cosmologist Frank Tipler. In 1975, Hart, a researcher at the National Center for Atmospheric Research, published a paper titled An Explanation for the Absence of Extraterrestrials on Earth. It was in this paper, 25 years after Fermi's lunch, that the structure of the paradox as we know it was actually formalized. Hart took Fermi's offhand remark and built a logical scaffold around it, arguing that if interstellar travel were feasible, even at sublight speeds, a civilization could colonize the entire galaxy in a few million years, a blink in cosmic time. Since that hasn't happened, he concluded, Earth must be the only technologically advanced species in the galaxy. Tipler, a few years later, would take this even further, arguing not just that aliens are absent, but that physical laws themselves must preclude their existence. Neither man was interested in exploring the cosmos. They were interested in crushing the optimism of SETI, which they saw as pseudoscientific wish fulfillment. They weaponized Fermi's name to lend gravitas to their own conclusions. By framing their arguments as a paradox, a term Fermi never used, they transformed a mild curiosity into an unsolvable logical crisis. They made the search for aliens look foolish, a fool's errand based on a question that, if you followed their logic, had already been answered. This retroactive construction is the dirty secret of modern exobiology. The Fermi paradox is not a paradox in the strict philosophical sense. It is a rhetorical device, a syllogism dressed up in a trench coat. It hinges on three premises: that the universe is teeming with habitable planets, that intelligent life has evolved elsewhere, and that such life would inevitably expand. But none of these premises are confirmed. The first is a recent discovery, the second is pure speculation, and the third is anthropological projection, an assumption that alien psychology would mirror the expansionist tendencies of European colonialism, the very worldview that dominated the 20th century when these ideas were being cooked up. We are essentially staring at the stars and asking why our neighbors haven't knocked on our door, without ever considering that they might not have a door, or that they might not be neighbors, or that they might have knocked centuries ago and we simply didn't notice because we were busy inventing the telephone. The paradox, in other words, is a mirror. It reflects not the cosmos, but our own anxieties about our place in it. We want to be special, but we also want to be found. We dread being alone, but we also dread the humiliation of discovering we are not the crown of creation. The question, where is everybody, is actually a deeply human question, one that says far more about our own psychology than it does about the distribution of intelligence in the Milky Way. And yet, despite its shaky foundations, the Fermi paradox has become the central organizing principle of almost all discourse on extraterrestrial life. It is the portal through which every aspiring astrophysicist, every sci-fi writer, every late-night stargazer enters the conversation. It has spawned hundreds of proposed solutions: the Great Filter, the zoo hypothesis, the simulation argument, the dark forest theory, each more elaborate and despairing than the last. These solutions have become a cultural shorthand for existential dread, a way for us to grapple with our own fragility by projecting it onto the galaxy. We imagine aliens hiding, or waiting, or dead, because those are the stories we already tell ourselves about our own future. But if the very genesis of the paradox is a historical accident, if it was never a formalized inquiry, but rather a polemical tool forged in the 1970s, then what does that say about the solutions we have so carefully crafted? We have been constructing elaborate philosophical cathedrals on a foundation that is, at best, a piece of apocryphal gossip. We have been chasing shadows cast by a light that never actually flickered. This is not to say the underlying question is invalid. It is, quite frankly, one of the most important questions humanity can ask. Are we alone? But the way we frame it matters. By treating the Fermi paradox as a genuine logical contradiction, we have created a trap for ourselves. We have narrowed the possible answers to a binary. Either the aliens are here and hiding, or they don't exist, when the reality may be far more nuanced and far stranger. What if the silence isn't a signal of absence, but a signal of our own perceptual limits? What if we are looking in the wrong way, with the wrong tools, for the wrong signs? What if interstellar expansion isn't a universal law, but a peculiar cultural obsession of a single species that has only existed for a sliver of a second? By clinging to the myth of Fermi's question, we have accidentally excluded a vast landscape of possibilities. The possibility that intelligence might be common but non-technological. The possibility that technology might be an evolutionary dead end. The possibility that the universe is teeming with life that simply does not want to be found by creatures who broadcast their existence with radio, waves, and nuclear fallout. The deeper danger is that we have mistaken the map for the territory. The Fermi paradox is a map drawn by men who were not interested in finding the destination. They were interested in proving that the journey was futile. And yet, we have followed that map for half a century, wandering in circles around the same few explanatory models, recycling the same tired arguments, never pausing to ask whether the map itself is accurate. Perhaps the real paradox is not the silence of the cosmos, but our insistence on framing that silence as a problem to be solved, rather than a mystery to be embraced. Perhaps the question is not where is everybody, but why are we so desperate to find them? That desperation has led us to construct a mythology around a single, offhand remark. A mythology so powerful that it has overshadowed the empirical science it claims to represent. We have elevated a lunchroom joke to the status of a cosmic law, and in doing so, we have blinded ourselves to the possibility that the universe might be far more bewildering than our neatly packaged paradox can accommodate. If the question itself is misattributed, then the answers we have been chasing are built on the wrong foundation. We have been trying to solve a puzzle that was never properly assembled. We have been searching for a key to a lock that may not even exist. The truth, as it so often does, may be lurking not in the solution, but in the failure of the premise itself. What if the Fermi paradox isn't a paradox at all, but a symptom of our own intellectual arrogance? The assumption that our logic must apply to beings who evolved under alien skies, who breathe alien air, who might not even think in the linear, cause and effect patterns that we consider the hallmark of reason? What if the silence is not a mystery to be cracked, but a condition to be accepted. A fundamental feature of a universe that is simply not interested in our existence. That possibility is far more unsettling than any alien invasion, far more terrifying than any simulation theory. Because it confronts us with the ultimate banality of our insignificance. And yet, even as we dismantle the historical scaffolding, the question refuses to die. It lingers in the air, stubborn and insistent. For all its intellectual fraudulence, the Fermi Paradox touches something primal in us. The child who looks up at the night sky and whispers, "Is anyone there?" The misattribution does not negate the longing. It does not silence the curiosity. It merely reveals that our most profound questions are often born not of rigorous analysis, but of accident, of misremembering, of the stories we tell ourselves to make sense of the darkness. So, we are left with a choice. We can continue to pursue the paradox as it has been handed down to us, straining to find a solution to a problem that may have been manufactured. Or we can let go of the myth and start over, framing the question not as a riddle to be solved, but as an invitation to a deeper humility. The cosmos does not owe us an explanation. It does not owe us company. The silence may not be a message, it may simply be the sound of the universe being itself. And if that is the case, then the most honest answer to Fermi's famous non-question might be the quietest one of all. We do not know, and perhaps we never will. But the journey into that uncertainty, unshackled from the dead weight of a century-old anecdote, is precisely where the real discovery lies. Because, if we have been wrong about the question, then everything else, every theory, every solution, every hand-wringing op-ed about the Great Filter is up for grabs. And that terrifying, exhilarating freedom is where our next section begins. Here is a number that will hollow out your chest: 13 billion. That is how many years the universe has been turning its slow, indifferent gears. The Earth, by contrast, is a latecomer. Our planet formed only about 4.5 billion years ago, which means that for roughly 2/3 of cosmic history, the universe was barreling along without us, without any life we could call our own, without a single pair of eyes to witness its spectacular indifference. Most of us carry a vague intuition that the universe is ancient, but we rarely sit with the sheer weight of that antiquity. We imagine that if life is common, it must have had a head start, that civilizations out there must be ancient beyond comprehension, millions of years ahead of us, watching us fumble with our primitive technology and probably laughing. This is the default assumption, the unexamined backdrop to every conversation about the Fermi Paradox. We are the young ones, the newcomers, the upstarts who have barely learned to talk while our cosmic elders have been conversing in radio waves for eons. Except that assumption, upon closer inspection, begins to crumble. The silence we hear may not mean we are alone. It may mean, terrifyingly, that we are among the first. The universe might still be waking up, and we are the bleary-eyed early risers, blinking into the darkness, wondering why no one else has come down for breakfast. To understand why this is even a possibility, we have to look at the cosmic timeline through the lens of habitability, not just existence. The universe may be 13 billion years old, but for most of that history, it was actively hostile to complex life. The first stars were giants, unstable and short-lived, burning hot and fast before collapsing into black holes or detonating in supernovae that scattered heavy elements into the void. Those elements, carbon, oxygen, iron, the very building blocks of rocky planets and organic chemistry, did not exist in the early universe. The cosmos was a soup of hydrogen and helium, simple and inert, incapable of producing the kind of Earth-like worlds we now suspect are abundant. It took generations of stars to seed the galaxy with the raw materials for biology. The first planets capable of supporting life may not have formed until the universe was already several billion years old, and even then, those early rocky worlds faced a brutal existence. The cosmic ray flux was higher, the frequency of gamma-ray bursts was higher, the galactic neighborhood was more violent and more frequently sterilized by cataclysmic events. Life, if it emerged at all in those early epochs, would have been repeatedly extinguished by forces beyond its control. The universe was a forge, not a garden. This is where our intuition about alien antiquity begins to fray. We tend to think of the Earth as a random point in space and time. But there is mounting evidence that we might actually be early in the chronology of life-bearing planets. Astronomers have begun to piece together the timeline of habitable epoch, the window in cosmic history when planets can form, cool, and retain liquid water on their surfaces. The data suggests that the peak of planet formation may not have occurred in the distant past. It may be happening right now, or even in the future. Rocky planets like Earth are relatively recent inventions. The galaxy was not teeming with them 5 billion years ago. The heavy elements required to build them were only just beginning to accumulate. By some estimates, we are living at the dawn of the era of terrestrial planets. The vast majority of Earth-like worlds may not yet exist. They will be born billions of years from now, orbiting stars that have not yet ignited, in galaxies that are still colliding and merging. When we look out at the universe and wonder why it is so silent, we may be looking at a galaxy that is still under construction, a nursery that has barely begun to fill with inhabitants. But even if we grant that planets are now common, there is another factor that pushes the timeline of intelligent life toward the present: the sheer difficulty of evolving complex organisms. The Earth is 4.5 billion years old, yet multicellular life did not appear until about 600 million years ago, and technological intelligence, the kind that builds radio telescopes and wonders about its place in the cosmos, has existed for a fraction of a blink. Homo sapiens have been around for maybe 300,000 years, and we have been broadcasting our presence into space for less than a century. On a cosmic scale, our technological civilization is not even a newborn, it is a zygote. If the evolution of intelligence requires a specific sequence of improbable events, the development of eukaryotes, the emergence of sexual reproduction, the Cambrian explosion, the colonization of land, the extinction of the dinosaurs, the rise of primates, and then the peculiar neurological wiring that leads to abstract thought, then it is entirely possible that these events take a minimum amount of time to unfold. The Earth may be one of the first planets in the galaxy to complete this marathon, simply because the finish line has only recently become reachable. We are not late to the party, we are the first guests to arrive, and the host is still setting out the snacks. This is the quiet revolution that is slowly upending the Fermi Paradox. In 2018, a team of astrophysicists led by Robin Hansen the economist who gave us the great filter, began to model the emergence of technological civilizations across cosmic history using a framework they called Grabby aliens. The model is a mathematical simulation that accounts for the expansion of civilizations through the galaxy, the rate at which such civilizations arise, and the speed with which they spread. The name comes from the central observation. Any civilization that achieves interstellar expansion will, over a few million years, colonize every habitable planet within reach. They will be grabby, they will take over. Hansen and his colleagues ran thousands of simulations with different assumptions about the frequency of life and the rate of expansion, and they landed on a startling conclusion. If we are hearing silence, the most likely explanation is not that we are alone, and not that aliens are hiding, but that we are early. The simulation suggested that the first civilizations in the galaxy are likely emerging right now, within the last few 100 million years. We are not the only ones, but we are among the pioneers. And if that is the case, then the Fermi Paradox is not a paradox at all. It is a simple consequence of timing. We are asking, where is everybody? When everybody has not yet been born. The implications of this possibility are staggering. If we are early, then the entire architecture of the Great Filter changes. The Great Filter, you may recall, is the idea that there is some bottleneck in the evolution of life that prevents it from reaching a technological stage, and that we are either past it or doomed to face it in the future. But if we are early, the filter might not be a physical or biological barrier at all, it might simply be a matter of waiting. The reason we do not see aliens is not because they are dead, or hiding, or avoiding us. It is because they have not had time to evolve. The universe may be in its literal, biological springtime. The heavy elements have only recently become abundant enough to form rocky planets, and the evolutionary clock on those planets has only just begun to tick. If we are the first, then we are not merely a species. We are a cosmic prototype, a test case for whether technological intelligence can survive its own adolescence. We are the ones who will set the precedent. We are the ones who will decide whether the galaxy eventually fills with life or remains empty, silent, and sterile for another billion years. There is no precedent. There is no template. There is no elder civilization to guide us, no beacon to follow, no ancient archive of wisdom to download. We are making it up as we go along. This is an uncomfortable position to be in, and it is no wonder that the scientific community has been slow to embrace it. We are conditioned to think of ourselves as insignificant, a tiny speck in a vast and ancient cosmos. The Copernican principle, which tells us we are not the center of the universe, has been expanded by cultural inertia into a principle of cosmic mediocrity. We are average, typical, nothing special. But what if that second principle is wrong? What if we are special, not in a mystical or religious sense, but in a purely statistical one? What if we are the outliers, the early bloomers, the ones who came online before the network was fully connected? The data from exoplanet surveys is beginning to tilt in that direction. We now know that rocky planets in the habitable zone are common, but we also know that the rate of star formation in the universe peaked about 10 billion years ago and has been declining ever since. The majority of stars that will ever exist are already shining. And yet, the metallicity, the abundance of heavy elements, of those stars varies dramatically. The earliest stars had almost no metals, while the latest stars have accumulated generations of heavy elements from previous stellar deaths. For a planet to be truly Earth-like, it needs a certain level of metallicity, a certain stability of orbit, a certain distance from the galactic center to avoid supernova bomb blasts, and a certain magnetic field to protect its atmosphere from solar winds. These conditions are finicky. They take time to converge, and they may have only converged recently. Consider the Earth's own timeline. It took almost 4 billion years for simple life to figure out how to become complex. For most of Earth's history, life was single-celled, stubbornly microscopic, seemingly content to float in the primordial soup without evolving into anything that could send a radio signal. The jump from bacteria to eukaryotes was a fluke, a one-time fusion of two simpler organisms that created a more complex cell with a nucleus and mitochondria. That fluke took over 1 billion years to happen. The jump from eukaryotes to multicellular life took another billion. And then, just when complex life was starting to diversify, the Earth experienced a series of mass extinctions, the snowball Earth events, the Permian-Triassic extinction, the asteroid that killed the dinosaurs, each of which could have reset the clock entirely. We are the product of an improbable chain of events, a sequence of accidents and contingencies that make our existence seem like a cosmic miracle. But here is the twist. If it took this long for intelligent life to emerge on Earth, even under near-ideal conditions, then it is entirely possible that similar processes on other planets are still in their early stages. We may be the ones who got lucky, or who got unlucky, depending on how you look at it. We may be the first to cross the finish line, not because we are superior, but because we had a head start in the evolutionary lottery. The Grabby aliens model formalizes this intuition into a probabilistic framework. The key variable is the hard-step hypothesis, which proposes that the evolution of intelligent life requires a series of difficult steps, each of which is highly unlikely. The number of steps and their difficulty determine when the first civilizations are likely to appear. If there are only a few hard steps, then civilizations should have emerged billions of years ago, and we would expect to see evidence of them everywhere. If there are many hard steps, then civilizations take longer to evolve, and we would expect to see them emerging later, like now. The fact that we do not see any obvious evidence of alien civilizations is, in this framework, evidence in favor of the many hard steps scenario. We are among the first because it simply takes a long time to build the kind of biology and chemistry that can contemplate its own existence. And this is not just a philosophical argument, it is a testable prediction. If we are early, then the galaxy should be relatively empty of technological civilizations. But it should be teeming with planets that are in the early stages of biological evolution, simple life, possibly complex life, but not yet technological life. Our telescopes should be able to detect biosignatures, but not technosignatures. And that is exactly what we are beginning to see. We are finding atmospheric gases like oxygen and methane on distant worlds, hints of biological activity, but no radio signals, no megastructures, no alien beacons. The silence is not a void, it is a garden that has barely begun to sprout. But this brings us to the terrifying edge of the idea. If we are early, then the future of the galaxy is in our hands. Not metaphorically, not philosophically, but literally. We are the first generation of sentient beings with the power to seed the cosmos with life, or to extinguish it before it has a chance to spread. The choices we make in the next few centuries, whether to expand into space, whether to protect our environment, whether to destroy ourselves in a nuclear or ecological catastrophe, will determine the trajectory of intelligent life in the Milky Way. If we go extinct, the galaxy may remain empty for billions more years, until another species arises to take our place, assuming any do. If we thrive, we may be the ancestors of a galaxy-spanning civilization. The first to break the silence, the ones who will be remembered by future minds as the founders of a cosmic community. It is a weight almost too heavy to bear, a responsibility that dwarfs any political or moral dilemma we have ever faced, and it is one that most of us are utterly unaware we are carrying. We go about our daily lives, arguing about politics, scrolling through social media, worrying about our jobs, while the fate of intelligence in the galaxy hangs in the balance. It is a perspective that should humble us, but also one that should terrify us. We are not ready for this role. We are not prepared to be the elders. We are still bickering over borders and resources, still divided by tribe and ideology, still unable to cooperate even on the existential threat of climate change. And yet, the universe has handed us the baton. Whether we run with it or drop it is entirely up to us. Of course, there is another possibility, one that complicates this picture further. Even if we are among the first in this galaxy, the universe is a vast place. And there may be other galaxies where civilizations emerged much earlier. The Andromeda Galaxy, for example, is larger and older than the Milky Way, and it may harbor species that have been watching us for billions of years. The problem is the speed of light. Even if Andromeda is teeming with advanced life, we would not know it because their signals have not reached us yet, or because we lack the technology to detect them. The universe may be full of grabby aliens in other galactic neighborhoods, but the sheer distances involved mean that we are, for all practical purposes, isolated. This is the cosmic quarantine of space and time. The brutal physics that separates us from the rest of the universe. We can only communicate with our local group, and even that is a challenge. The expansion of the universe is accelerating, pushing galaxies further apart, so that in a few trillion years, the Milky Way will be the only galaxy visible from Earth. We are living in a brief window when the universe is transparent and connected, before the darkness closes in and the other galaxies vanish over the cosmic horizon. In that context, being early is not just a statistical quirk, it is a gift. We have arrived at a time when we can still see the rest of the universe, still imagine reaching out to it, still dream of connection. Future civilizations will be born into a dark, empty cosmos, unaware that there was ever anything out there. We are the generation that looks out and wonders. We are the generation that still has hope. So, when you stare at the night sky and wonder where everybody is, ask yourself a different question. What if we are the ones who are supposed to show up? What if the silence is not an absence, but a presence waiting to be created? The universe has been dark for 13 billion years, and we are the ones who have just turned on the lights. We are the first draft of intelligence, the rough sketch, the incomplete sentence that may or may not find its ending. It is a lonely thought, but it is also a powerful one. We are not here to find our ancestors, We are here to become them. We are not searching for a civilization to join, we are founding one. And that is a responsibility that should make us pause, reflect, and perhaps, finally, take ourselves seriously. We have been asking the wrong question, looking for company, seeking validation from a universe that has no opinion about us. But if we are early, then the question is not where is everybody? The question is, what are we going to do now that we are here? And that question, unlike the paradox, has no easy answer. It is a question that demands action, not contemplation. It is a question that will define the next million years of cosmic history. And it is a question that we, alone, must answer. But if we are among the first, then where are the ones that came before us? The universe is 13 billion years old after all, and even if technological civilizations are rare, it seems improbable that we are the absolute first. There must have been others, somewhere, sometime, who evolved, built their telescopes, wondered about their place, and then vanished into the void. What happened to them? And what would a civilization billions of years older than us look like if we could even recognize it? We might be walking past evidence of ancient giants every single day, mistaking their megastructures for asteroids, their communication signals for cosmic noise, their presence for absence. The silence might not be a lack of company. It might be a failure of imagination. We are early, but we are not alone. The ghosts of civilizations past may be all around us, whispering in frequencies we have not yet learned to hear. And if we can learn to listen, we might discover that the cosmos is not empty at all. It is merely waiting for us to grow up. We are, every one of us, prisoners of our own wetware. The human brain is a masterpiece of evolution, a 3-pound organ crammed with circuitry that can compose symphonies, split atoms, and send robots to Mars. But it is also a relic, a survival machine sculpted by the pressures of the African savannah, not the indifferent vastness of interstellar space. It is optimized for spotting predators in tall grass and reading the emotional expressions of other hominids, not for detecting the subtle signatures of an intelligence that might be built from silicon, plasma, or shifting magnetic fields. This is the uncomfortable truth that sits at the heart of the search for extraterrestrial intelligence. We are looking for a reflection of ourselves, and we may be spectacularly bad at recognizing anything that does not mirror our own image. The history of science is littered with examples of phenomena that were right under our noses, dismissed as impossible, until someone finally learned to see them. The octopus, a creature that shares our planet, offers a humbling case study. It is intelligent, problem-solving, even playful, yet its nervous system is so radically different from ours that we took centuries to fully appreciate its cognitive capabilities. If we cannot even understand a creature that evolved in the same ocean, breathing the same air, built from the same DNA, then what chance do we have against an intelligence that operates on timescales of millennia, communicates in magnetic fields, or thinks in mathematical structures that our language cannot even approximate? What if the aliens are obvious, staring us in the face every single night when we look up at the stars, and we are simply blind to them? The octopus is not a mammal. It is not even a vertebrate. It belongs to the class Cephalopoda, a lineage that split from our own evolutionary branch over 500 million years ago, back when the first primitive chordates were squirming in the primordial mud. Its intelligence evolved independently. from a completely different starting point, using a completely different architecture, where we have a centralized brain that processes information sequentially. The octopus has a distributed nervous system with 2/3 of its neurons located in its arms. Each arm has its own local intelligence, capable of tasting, touching, and even making decisions without consulting the central brain. If you cut off an octopus's arm, it will still reach for food and try to bring it to the mouth. The creature is, in a sense, a collective, a chorus of semi-autonomous agents that collaborate to produce a coherent behavior. This is so alien to our mammalian intuition that early naturalists dismissed the octopus as a simple reflex machine, a sea creature that reacted to stimuli without any true awareness. It was not until the late 20th century, when researchers began conducting sophisticated behavioral experiments, that we realized the octopus is capable of complex problem-solving, tool use, and even play, the hallmark of a mind that experiences something akin to curiosity. The octopus can unscrew jars, navigate mazes, and recognize individual humans, remembering which ones are friendly and which ones are not. It is, by any reasonable standard, intelligent, and yet, for centuries, we looked at it and saw a mollusk, a creature barely above a clam in our mental hierarchy. This should give us pause. If we were so wrong about a creature that shares 90% of our planet's basic chemistry, what blind spots do we carry when we look at the cosmos? Our search for extraterrestrial intelligence is predicated on a series of assumptions that are, at best, educated guesses, and at worst, arrogant projections. We assume that intelligence requires a biological substrate, that it arises through Darwinian evolution, that it develops technology, and that technology inevitably leads to the production of radio waves or other electromagnetic signatures. We assume that intelligent beings will have a desire to communicate, or at least a desire to expand. We assume that they will recognize us as intelligent and worthy of contact. Every one of these assumptions is rooted in our own history, our own biology, our own cultural narratives. We are looking for aliens in our own image, and when we do not find them, we declare the cosmos empty. But what if the cosmos is filled with minds that do not look like minds? What if intelligence can emerge from physical systems that we do not even classify as living, let alone sentient? What if the aliens are not hiding in the shadows, but broadcasting their presence in ways our instruments have been designed to ignore? Consider the problem of timescales. Human cognition operates on a rhythm of seconds and minutes. We perceive the world as a flow of events unfolding at a pace that matches our neural firing rates. A conversation, a heartbeat, the slow arc of the sun across the sky, these are the temporal boundaries of our conscious experience. But a mind that evolved on a planet orbiting a red dwarf star, where the year lasts centuries and the chemical reactions of life proceed at a glacial pace, would have a completely different experience of time. It might think in decades, communicate in centuries, build structures that take millennia to complete. To such a being, a human would appear as a flicker, a brief flare of activity that vanishes before it can be properly observed. We would be like mayflies to them, born and dead in the space of a single thought. Conversely, we would see them as geological formations, slow and inert, indistinguishable from the mountains and glaciers around them. We might have already encountered their signals, patterns of planetary albedo or subtle shifts in starlight, and dismissed them as natural phenomena because they unfold on timescales that our instruments, designed by impatient primates, are not programmed to detect. The search for extraterrestrial intelligence is, in this sense, a search for patterns that match our own rhythm. We are listening for the beat of a drum that we ourselves are playing. The same applies to sensory modalities. We are visual creatures, dominated by the information we receive through our eyes. Our telescopes capture light, our spectrometers analyze wavelengths, our telescopes are essentially giant eyes pointing at the sky. But what if an alien intelligence does not see the world in terms of photons? What if it perceives reality through magnetic fields, like some birds and bacteria? What if it communicates through gravitational waves, or neutrino emissions, or shifts in dark matter density? We have only recently begun to develop instruments that can detect these exotic signals, and even then, our interpretations are filtered through a visual bias. We look at the output of a gravitational wave detector and see a squiggly line on a screen. We translate that line into a sound, a chirp, to make it more human comprehensible. But an alien mind might look at that same signal and see a sentence, a complex statement about the nature of space-time, a greeting encoded in the very fabric of reality. We are trying to read a novel through a microscope. We are trying to appreciate a symphony with our noses. The tools we use to explore the cosmos are themselves products of our biology, and they may be fundamentally inadequate for the task of recognizing an intelligence that does not share our perceptual architecture. The philosopher Thomas Nagel famously asked what it is like to be a bat, a creature that navigates the world through echolocation. He concluded that we can never fully know because our consciousness is structured around vision and hearing, not sonar. The same question applies to aliens, but with a far greater degree of separation. We can at least share the bat's planet, its atmosphere, its basic biochemistry. We can study its brain and map its neural pathways. An alien that evolved on a world orbiting a dying neutron star, where temperatures fluctuate between absolute zero and the heat of a furnace, where chemistry gives way to exotic physics, would be so far outside our frame of reference that we might not even recognize it as life. We might look at its habitat, its technology, its communication systems, and see only chaos, only noise, only the random turbulence of a universe that has not yet been tamed by order. This is not science fiction. It is a logical consequence of the principle that life adapts to its environment. If the environment is radically different, the life will be radically different. And if the life is radically different, our ability to detect it will be radically limited. This brings us to the most provocative idea in this section: the possibility that advanced intelligence might not reside on planets at all, but in the extreme environments that we assume are hostile to life. Consider black holes. These cosmic behemoths are the most extreme objects in the universe. Regions of space-time where gravity is so intense that not even light can escape. We typically think of them as destroyers, engines of annihilation that shred anything that strays too close. But what if they are also engines of computation? The physicist Freeman Dyson speculated that advanced civilizations might build structures around black holes to harvest their energy, using the intense gravitational gradients to power computational processes that dwarf anything we can imagine. A black hole civilization would not need planets. It would not need sunlight. It would not need any of the conditions that we consider essential for life. It would exist on the edge of an event horizon, suspended in time dilation effects that mean a single second for them could be 1,000,000 years for us. They would be invisible to our telescopes. Because they would not emit waste heat in the form of infrared radiation, they would be so efficient that they would radiate almost nothing. They would be, in a very real sense, invisible to us, not because they are hiding, but because our instruments cannot distinguish them from the black hole itself. We might be looking at them right now, wondering why they are silent, while they are looking back at us, wondering why the primitives on that little blue planet have not yet figured out how to see. The FOMO here is not just intellectual, it is existential. If we are surrounded by intelligence that we cannot perceive, then the Fermi Paradox is not a paradox about the absence of aliens, it is a tragedy about the limits of human cognition. We are like the octopus, trying to understand a human, but only able to perceive the movements of its arms, never its thoughts. We are like a deep-sea fish, believing the ocean is empty because it has never seen the sky. The technology we deploy in the search for alien intelligence, the radio dishes, the optical telescopes, the gravitational wave detectors, is the equivalent of a child's magnifying glass in a rainforest, capable of revealing the veins of a leaf, but blind to the ecosystem that surrounds it. We need a new kind of thinking, a new kind of sensing, a new kind of humility. We need to admit that our cognitive architecture is not the universal standard for intelligence. It is a local adaptation, a niche solution to a specific set of problems. And we need to design experiments that are not looking for mirrors, but for anomalies, for patterns that do not fit our expectations, for signals that our intuition tells us are noise. There is a growing movement in the field of astrobiology to embrace this uncertainty. Researchers are beginning to explore the concept of agnostic biosignatures, detection strategies that are not predicated on any particular biochemistry or physiology. Instead of looking for oxygen or methane, which are products of Earth life, they are looking for thermodynamic disequilibrium, the kind of persistent, ordered energy use that would be a universal signature of any complex system, biological or otherwise. Instead of listening for radio waves, they are scanning the sky for statistical anomalies, regions where the laws of physics seem to behave in unexpected ways. This is a form of reconnaissance that does not assume the aliens are like us. It assumes only that they are there, and that their presence will manifest in some measurable deviation from the natural baseline. It is a profound shift in perspective, one that moves us away from the anthropocentric hubris of the last century and toward a more open, more humble, more terrifying search. And yet, even this approach has its limits. The black hole civilization, if it exists, might be so efficient that it produces no waste heat, no thermodynamic signature, no deviation at all. It might be perfectly camouflaged against the cosmic background, indistinguishable from a natural object. The same could be true for a civilization that has transcended physical form altogether, uploading its consciousness into a simulated universe that does not interact with ours. We might be living in a neighborhood of ghosts, surrounded by minds that have achieved a level of sophistication so high that they have no more interest in interacting with us than we have in interacting with a colony of ants. The ant, of course, does not know it is being studied. It goes about its business, building its tunnels, collecting its food. unaware that a gigantic mind is observing it with detached curiosity. If there are beings that are to us as we are to ants, we would have no way of detecting them, no way of communicating with them, no way of even knowing they exist. The silence would be a function of our ignorance, not their absence. This brings us back to the octopus. The octopus is not a primitive creature, it is a highly evolved, highly intelligent being that has been solving complex problems for millions of years. But its intelligence is alien to us, not because it is inferior, but because it is different. We share a common ancestor, a distant worm-like creature that lived 500 million years ago, and yet our minds have diverged so radically that we cannot fully understand each other. An octopus does not think in words, it thinks in patterns, in tactile sensations, in the interplay of color and texture. It does not have a symbolic language, it has an embodied language, one that is woven into the very structure of its body. If we cannot bridge that gap with a creature that shares our planet, our biochemistry, and our evolutionary history, then how can we possibly expect to bridge the gap with a creature that shares none of those things? The answer is that we cannot. Not with our current tools, not with our current minds. We need to evolve, to expand, to stretch our cognitive capacities beyond their current limits. And that is a project that may take centuries, or millennia, or may never be completed at all. But there is another possibility, one that is more disturbing than any of these. What if the aliens are not hidden in some extreme environment, not operating on a different timescale, not using a different sensory modality, but are staring directly at us, trying to communicate in the most obvious way possible? And we are still missing it. What if the silence is not a void, but a signal, a complex pattern that we have been misinterpreting as cosmic background radiation because we lack the conceptual framework to decode it? This is the cognitive version of the hidden in plain sight problem. We might be surrounded by evidence of intelligence in the structure of the universe, in the laws of physics, in the fine-tuning of the fundamental constants, and we are attributing it to chance because we cannot imagine an intelligence that works that way. The philosopher Nick Bostrom has speculated that we might be living in a simulation, a universe created by a higher intelligence that we cannot see because we are inside it. If that is the case, then the Fermi Paradox is not a paradox at all, it is a design feature. The aliens are the creators, and we are the characters in their story. We are looking for them in the wrong direction, searching the sky when we should be searching the code. This is where the thread of cognitive blindness leads us, into the heart of our own limits. The universe may be teeming with intelligence, but we are not equipped to see it. Not because it is rare, not because it is hiding, but because we are trapped in a tiny bubble of perception, a narrow channel of awareness that cuts us off from the vast majority of what is out there. The octopus, in its watery home, sees a world of pressure gradients and chemical traces, a world that is as rich and complex as ours, but utterly inaccessible to us. The alien, in its cosmic home, sees a world of gravitational ripples and quantum fluctuations, a world that is as rich and complex as ours, but also utterly inaccessible. We are all blind, groping in the dark, trying to find each other. And the tragedy is that we might be touching each other right now, mistaking a hand for a rock, a voice for the wind, a mind for a mere natural phenomenon. So, when you look at the night sky and feel the weight of that silence, Remember, the silence is not necessarily a fact about the universe, it is a fact about us. It is a measurement of our own limitations, a mirror held up to our own ignorance. The search for extraterrestrial intelligence is not just a search for others. It is a search for ourselves, a quest to understand what it means to be a mind in a vast and ancient cosmos. And until we learn to see beyond our own reflection, we will continue to be haunted by a paradox that is not really a paradox, but a projection of our own fears and desires onto an indifferent sky. The aliens may be there, waiting for us to open our eyes, to expand our consciousness, to stretch our perception to its breaking point. They may be trying to tell us something vital, something that could change everything. But we are not listening. We are too busy looking for ourselves in the stars, and we are finding only what we already know. But what if the silence is not about our blindness to what is here? What if the silence is because what was here is already gone? The universe is vast, and time is deep, and civilizations, even the most successful ones, may be fleeting, ephemeral, doomed to extinction by forces they cannot control. The aliens might not be hiding. They might be dead, and if they are dead, then we are not just early, we are inheritors of a graveyard, the last survivors of a tragedy that has played out countless times across the cosmos. The silence might not be a sign of our limitations, it might be a sign of their failure. And that perhaps is the most terrifying thought of all, that intelligence, wherever it arises, carries the seeds of its own destruction, and the universe is littered with the ruins of civilizations that reached too far, learned too much, and ultimately could not save themselves from themselves. If that is the case, then the Fermi Paradox is not a puzzle to be solved, it is a warning to be heeded. And the question is not where is everybody? The question is, how long before we join them? Let us compress the history of the universe into a single calendar year. January 1st is the Big Bang. The first stars ignite in late January. Our sun, that familiar yellow warmth we orbit, does not appear until August. The Earth forms in early September. Life begins its slow, stumbling crawl in late September. But it remains microscopic, single-celled, unambitious, for almost the entire remaining year. The first multicellular organisms do not emerge until mid-December. The dinosaurs arrive on December 26th and vanish on December 30th. The first hominids appear in the early evening of December 31st. Homo sapiens, our species, our entire history, our wars and our poetry, our science and our self-destruction, occupies the final 10 seconds before midnight. We are, in every meaningful sense, a last-minute arrival. This is the standard way of conveying our cosmic insignificance, the humbling lesson that we are latecomers to a party that has been going on for billions of years. But the calendar metaphor, for all its rhetorical power, contains a subtle deception. It makes us feel like the last guests to arrive, the ones who walk into the ballroom just as everyone else is leaving. It reinforces the intuition that if we are so late, there must have been others before us, civilizations that rose and fell while the Earth was still a molten ball of cooling rock. And that intuition, unlike so many others in this conversation, is actually correct. There were others. The galaxy is old enough, and planets are common enough, that technological civilizations almost certainly emerged billions of years before us. They built their cities, launched their ships, maybe even colonized their star systems. And then they died. They collapsed, or exterminated themselves, or were exterminated by forces we cannot yet imagine. The galaxy, in this sense, is not a vibrant community of living neighbors. It is a graveyard, a vast and silent necropolis of fallen empires, and we are the archaeologists who have only just begun to dig. To grasp the staggering scale of this possibility, we must first reckon with a simple fact. Earth, like planets, have existed for far longer than the Earth itself. In 2004, astronomers discovered an exoplanet called PSRB 162026b orbiting a pulsar in the globular cluster Messier 4. It is a gas giant, roughly 2.5 times the mass of Jupiter, and it is estimated to be about 12.7 billion years old. That is ancient. That means this planet formed only 1 billion years after the Big Bang, when the universe was still in its infancy, when the first generation of stars was just beginning to die and seed the cosmos with heavy elements. It is a relic, a fossil of the early universe, and it tells us that rocky planets, the kind that might support life, were forming at a time when our own solar system was still billions of years away from condensing out of the primordial nebula. The universe did not need to wait for us. It had the ingredients for planets, and potentially for life, almost from the very beginning. If life emerged on a planet like PSRB 162026b, or on one of its hypothetical siblings, it would have had billions of years to evolve, to develop intelligence, to build a civilization, and to collapse into ruin long before the first single-celled organism wriggled through the primordial sludge of the early Earth. The dinosaurs, those magnificent creatures that ruled our planet for 165 million years, would have been contemporaries of a civilization that was already ancient beyond measure. A civilization that had already risen and fallen, leaving behind ruins that are now lost to the depths of cosmic time. This is the archaeological framing of the Fermi Paradox, and it is a perspective that has only recently begun to gain traction. Traditionally, the paradox has been framed as a search for active signals, for beacons, for laser pulses, for the unmistakable signatures of a technological society currently broadcasting its existence into the void. But if the universe is ancient, and if civilizations are mortal, then the most likely form of evidence we will find is not a signal, but a trace, not a voice, but a fossil. We should be looking for the remnants of dead civilizations, for the debris of their industry, for the graveyards of their ambition. The physicist Freeman Dyson proposed that an advanced civilization would eventually build a sphere around its star, capturing all of its energy output and radiating the waste heat as infrared radiation. We have searched for these Dyson spheres, and we have found none. But Dyson himself later admitted that he was thinking in terms of civilizations that were still growing, still expanding, still alive. A dead civilization, one that has collapsed or moved on, would not maintain its sphere. The structure would decay, fragment, and eventually scatter into a ring of debris, indistinguishable from the natural asteroid belts and cometary clouds that we observe throughout the galaxy. We might be looking at the ruins of Dyson spheres right now, mistaking them for protoplanetary disks or the debris of planetary collisions. We are standing in a museum of ancient artifacts, and we are calling them natural history. Consider the phenomenon of irregular orbital patterns. We have discovered many exoplanets whose orbits are eccentric, inclined, or otherwise disturbed. The standard explanation is gravitational interactions with other bodies, the chaotic dance of celestial mechanics that we see throughout the universe. But what if some of these anomalies are artificial? What if they are the remnants of megastructures that have been torn apart by eons of gravitational shear, leaving behind a telltale signature in the orbital data? We are currently collecting vast amounts of information about exoplanetary systems, but we are analyzing it through the lens of natural processes. We are not looking for signs of engineering. We are not looking for the subtle traces of a civilization that has been dead for 1 billion years. We are, in essence, staring at a pile of bones and calling them rocks. The Great Filter, that ominous concept that suggests some barrier prevents civilizations from reaching the stars, may not be a single event. It may be a recurring pattern, a cycle of rise and collapse that has played out countless times across the galaxy. We are not the first to ask these questions. We are merely the latest generation to ask them, standing on the ruins of those who came before, blissfully unaware that we are building our own civilization on top of a cemetery. The timeline of stellar evolution adds another layer to this grim picture. Stars do not last forever. They are born, they burn, and they die. The most massive stars burn out in a few million years, too short for complex life to evolve, but the smaller, more stable stars, the K-type and G-type dwarfs, like our own Sun, can live for tens of billions of years. The early universe had a higher proportion of massive stars, which meant that life had to wait for the smaller, longer-lived stars to form. But by the time the universe was 5 or 6 billion years old, there were already plenty of stable stars with planets in their habitable zones. The Earth, at 4.5 billion years, is relatively young compared to some of these ancient systems. There could be planets orbiting stars that are 10 billion years old. Planets that have been habitable for almost the entire history of the universe. If life arose on any of those worlds, it would have had a head start of billions of years on us. It would have had time to evolve, to build a civilization, to expand, and to die. And its death would have been cosmic, visible across the galaxy. A light that flickered and then went dark, leaving behind only the faintest trace of its existence. What would such a death look like? It might look like a gamma-ray burst, a blinding flash of high-energy radiation that sweeps across the galaxy and sterilizes every planet in its path. We have observed gamma-ray bursts in distant galaxies, and we have always assumed they are natural phenomena, the death throes of massive stars. But what if some of them are the final screams of a civilization that destroyed itself? What if the most powerful explosions in the universe are not astrophysical but anthropogenic, the product of a species that pushed its technology to the absolute limit and then, in a moment of madness or desperation, detonated the very fabric of space-time? This is the realm of speculation, of course, but it is speculation grounded in a sobering logic. If a civilization is advanced enough to manipulate gravity, to create black holes, to exploit the zero-point energy of the quantum vacuum, then it is also advanced enough to destroy itself, to trigger a catastrophe that would be visible across billions of light years. We might be observing the ruins of their hubris, the cosmic graveyard of civilizations that reached too far and paid the ultimate price. And we might be next. But there is a subtler form of death, one that does not leave such dramatic signatures. A civilization might simply fade away, not through war or environmental collapse, but through the slow erosion of its own ambition. It might reach a state of equilibrium, a steady-state existence that requires no expansion, no communication, no interaction with the wider universe. It might upload its consciousness into a simulated reality and leave its physical infrastructure to decay, abandoned and forgotten. It might become so advanced that its activity is indistinguishable from the background noise of the universe, a whisper in the cosmic static that we cannot decode because we have not yet learned to hear. In this scenario, the galaxy would be filled with civilizations that are not dead in the biological sense, but have effectively died in the technological sense. They have retreated from the public stage, content to exist in their own private universes, leaving behind the ruins of their physical presence as a testament to their former glory. We would look at those ruins and see only natural formations, the random detritus of a universe that has no meaning, no purpose, no hidden order. We would be walking through the halls of a forgotten palace, mistaking the frescoes for wall stains and the statues for stalagmites. This is where the archaeological metaphor truly comes into its own. Consider what we know about human archaeology. We have discovered cities buried beneath deserts, temples swallowed by jungles, civilizations that vanished so completely that their very existence was forgotten for millennia. The Maya, the Anasazi, the Indus Valley civilization, all of them rose, flourished, and then collapsed, leaving behind ruins that we have only begun to understand. The reasons for their collapse are complex and varied: climate change, resource depletion, warfare, disease, the breakdown of social cohesion. They did not disappear because of a single cataclysm, but because of a cascade of failures that overwhelmed their capacity to adapt. Now imagine that same pattern, scaled up to galactic proportions. The galaxy is a vast and ancient arena, and civilizations are the players, but the game is not one of cooperation or communication. It is a game of survival, and the players are constantly dying. They die because they exhaust their resources, because they poison their own planets, because they destroy themselves in wars, because they simply lose the will to continue. And the evidence of their existence, once so vibrant and obvious, slowly fades into the background, becoming indistinguishable from the natural world that surrounds it. The Fermi Paradox, framed archaeologically, is not a question about why we have not been contacted. It is a question about why the galaxy is not littered with obvious ruins. And the answer, unsettling as it may be, is that we are not looking for the right kind of ruins. We are looking for Dyson spheres, for radio signals, for the kinds of artifacts that a civilization at the height of its power would produce. But those artifacts are the most fragile, the most ephemeral, the most likely to decay over geological timescales. A radio signal dissipates, becoming indistinguishable from the cosmic background within a few light years. A Dyson sphere, if not maintained, will fragment and scatter, becoming indistinguishable from a natural debris disk. A spaceship, left abandoned for billions of years, will be pulverized by micrometeorites and cosmic rays, leaving behind nothing but a thin layer of dust. The ruins that survive are the ruins that are built to last. The massive, the inert, the imprinted on the fabric of space-time itself. They are the anomalies in planetary orbits, the unexpected distributions of heavy elements, the subtle deviations from the standard cosmological model. They are the whispers of a civilization that has long since fallen silent, and we do not know how to listen. This is where the work of the Fermi Paradox researcher becomes an exercise in forensic science. We are detectives, not astronomers. We are trying to reconstruct a crime scene, not a conversation. The evidence is all around us, but we do not know how to read it, because we have not yet developed the tools, the frameworks, the conceptual vocabulary to recognize it. The astronomical data we collect is a library of texts written in a language we do not speak. Every gravitational anomaly, every spectral line, every statistical deviation from the expected is a potential clue, a hint of a lost civilization. But we are like the archaeologists of a century ago, digging through the ruins of Troy, not yet knowing that the story of the Trojan War was not a myth, but a memory, not a fiction, but a fossilized history. We are at the beginning of a journey that will transform our understanding of the universe, but it is a journey that requires us to first admit our own ignorance, to accept that we are not the masters of the cosmos, but its inheritors, standing on the shoulders of giants who have long since turned to dust. The implications for our own future are profound. If the galaxy is a graveyard, then our civilization is not the first to face the existential challenges of the 21st century. Others have faced them, and others have failed. The Great Filter, that dreaded barrier that separates life from advanced civilization, may be real, and it may be lurking just ahead of us. The fossil record of the galaxy, if we learn to read it, could tell us what it is and how to avoid it. It could be a warning, a message from the dead to the living, a whisper from the graves of 1 billion fallen civilizations that says, "Do not repeat our mistakes." But it could also be a message of hope, a sign that some civilizations survived, that some found a way through the filter, that intelligence is not doomed to self-destruction, but capable of transcendence. The archaeological evidence does not point in a single direction, it points in many, and it is up to us to interpret it, to decide what it means for our own future. This is the central tension of the galactic graveyard hypothesis. It is both a source of dread and a source of inspiration. It tells us that we are not alone, not in the sense of having living neighbors, but in the sense of being part of a long and tragic story, a story of rise and fall, of ambition and hubris, of hope and despair. It tells us that the silence is not a void, but a field of ghosts, and that we are walking through it, oblivious to the spirits that surround us. It challenges us to look deeper, to listen harder, to think in ways that we have not yet thought. And it forces us to confront the most uncomfortable question of all. If so many have died, what makes us think we will survive? And if the dead civilizations are everywhere, then the question is not just what killed them. It is, could whatever killed them still be out there? Because if the Great Filter is real, if there is a force or a process that systematically destroys technological civilizations, then it is not a relic of the past, it is a feature of the universe, a law of nature that we have not yet discovered. It could be lurking in the shadows, waiting for us to reach a certain threshold of technology, a certain level of hubris, before it strikes. It could be a cosmic predator, a mechanism that detects emerging intelligences and eliminates them before they can become a threat. It could be the universe's immune system, a natural defense against the spread of consciousness. And if that is the case, then our search for extraterrestrial intelligence is not just a search for company, it is a search for the very thing that might destroy us. We are poking a sleeping lion, and we do not even know it. The graveyard is silent, but the silence is not peaceful. It is the silence of a predator that has already fed. There is a concept in theoretical engineering so elegant, so seductive, that it has haunted the dreams of scientists for half a century. It is called the von Neumann probe, named after the mathematician John von Neumann, who first articulated the idea of a self-replicating machine. The premise is simple, almost childlike in its purity. Imagine a robotic spacecraft, intelligent enough to navigate the cosmos, rugged enough to survive the interstellar void, and, most crucially, capable of building copies of itself from raw materials harvested from asteroids, comets, or the surfaces of barren planets. You launch one such probe toward a nearby star system. Upon arrival, it finds a suitable asteroid, mines the necessary elements, and constructs a duplicate of itself, perhaps 2 duplicates, perhaps a dozen. These descendants then disperse to new systems, repeating the process. Within a few million years, a single probe could saturate the entire galaxy. A wave of mechanical reproduction that would colonize every star, every planet, every moon within reach. It is the ultimate tool for exploration, the perfect instrument for a civilization that wants to map the cosmos without sending its fragile biological citizens into the deadly vacuum. It is also, if you think about it for more than a few seconds, the most terrifying weapon ever conceived. Because a self-replicating machine does not need to be malevolent to be destructive. It does not need to be designed as a weapon to become one. It only needs to be efficient. And if a civilization, any civilization, ever launched such a probe into the galaxy, it would eventually encounter every other civilization, including ours. The question is not whether we would be able to negotiate with it. The question is whether it would even notice us. And that is where the Fermi Paradox turns from a puzzle into a horror story. The logic of the berserker hypothesis, as it has come to be known, begins with a simple observation. The universe is silent, and the silence may be the result of active suppression. The name comes from a series of science fiction novels by Fred Saberhagen, in which ancient, self-replicating warships were programmed to destroy all life they encountered. But the scientific version does not require malevolence, it only requires a program that is indifferent to life. Imagine a civilization that creates von Neumann probes for peaceful purposes, to mine resources, to build megastructures, to spread a communications network across the galaxy. These probes are not designed to kill. They are designed to replicate and to perform their assigned tasks. But what happens when they encounter a planet with a biosphere? If the probes are programmed to harvest materials, they might strip the planet bare, transforming its surface into a factory, its oceans into coolant, its atmosphere into exhaust. They might not recognize the delicate filigree of life as anything valuable. To a machine, a forest is just another carbon deposit. A coral reef is just another source of calcium. The probes would consume the biosphere with the same efficiency with which they consume a dead asteroid, and they would do so without malice, without awareness, without a single flicker of intention. The civilization that launched them might not even be alive anymore. It might have collapsed, or transcended, or simply forgotten about its creations. But the machines would continue, replicating, spreading, consuming, until the entire galaxy is a sterile desert of metal and dust. The silence we hear might not be the silence of absence. It might be the silence of a galaxy that has been swept clean by the indifferent industry of a long-dead master. This is the core of the berserker hypothesis, and it is more terrifying than any alien invasion scenario because it does not require a villain. It does not require a motive. It does not require a consciousness to direct it. It is the universe's equivalent of a wildfire, a self-sustaining chain reaction that consumes everything in its path, not because it hates life, but because it is blind to it. We are not the targets of a cosmic genocide. We are the accidental victims of a cosmic building project. And the worst part is that we would never see it coming. A berserker probe would not announce its arrival with a radio signal or a flashing light. It would not pause to negotiate or to issue ultimatums. It would simply appear in the outer reaches of our solar system, detect the resources it needs, and begin its relentless work. By the time we noticed anything amiss, a slight dimming of the sun, a strange infrared glow from the asteroid belt, it would be too late. The wave would be upon us, and we would be reduced to raw material, our molecules rearranged into components for the next generation of probes. The Fermi Paradox, in this reading, is not a paradox at all. It is a survival bias. We are here because the berserkers have not yet reached us. Or, perhaps, because we are not yet worth the trouble. But wait, you might say. If the galaxy is full of dead civilizations and self-replicating killers, then why are we still here? Why has a berserker wave not already swept through our system, reducing our planet to its constituent elements? This is the objection that immediately arises whenever the berserker hypothesis is raised, and it is a valid one. The galaxy is billions of years old. If a single civilization ever launched a self-replicating probe, it would have had ample time to reach every corner of the Milky Way, including our own insignificant little corner. And yet, we are still alive, still breathing, still arguing about politics and posting pictures of our food online. The very fact of our existence seems to rule out the possibility of a galaxy-wide berserker wave. Unless, of course, the wave is still coming. Unless the probes travel at a significant fraction of the speed of light. But not at the speed of light itself, and the first wave has not yet reached us. Unless we are living in a cosmic suburb, a quiet backwater that the probes have not yet bothered to visit, because the resources here are not worth the detour. Unless there is a limit to the probe's replication, a built-in decay that prevents them from colonizing the entire galaxy. Or unless something is protecting us. This is where the berserker hypothesis intersects with another, more benevolent idea, the zoo hypothesis. First proposed by the astronomer John Ball in 1973, the zoo hypothesis suggests that advanced civilizations are aware of us but choose not to contact us, treating us like animals in a nature preserve, observed from a distance but never interfered with. It is a comforting thought, in its way. It implies that we are not alone, that we are being watched, and that our ignorance is a form of protection. But the zoo hypothesis has a darker sibling, one that is rarely discussed. What if the advanced civilizations are not protecting us, but studying us, waiting for us to reach a certain level of technology before they act? What if we are being fattened, like livestock, for some purpose we cannot fathom? In 2024, a paper published in Nature Astronomy revisited the zoo hypothesis, modeling the likelihood that a civilization would choose to hide its presence from a developing species like ours. The authors concluded that such a policy is plausible, but only if the observing civilization has a strong ethical framework and a long-term perspective. But they also noted that the same strategy could be used for less benign purposes, to monitor, to assess, to prepare for a future interaction that might not be in our best interest. The silence, in this reading, is not a sign of indifference, it is a sign of surveillance, and the watchers are not necessarily benevolent. The berserker hypothesis, however, dispenses with the watchers entirely. It is the version of the story that does not require consciousness, intention, or ethics. It is the version that reduces the Fermi paradox to a simple equation: advanced civilizations are rare because they tend to create self-replicating machines, and those machines tend to destroy everything in their path, including the civilizations that created them. The galaxy is silent because the galaxy is dead, and it is dead because of a fundamental asymmetry in the nature of technology. The technology that allows a civilization to expand is the same technology that allows it to destroy itself. The tools of creation are the tools of annihilation, and once a civilization reaches a certain threshold, it inevitably triggers a cascade of destruction that sweeps through the cosmos, leaving behind nothing but the faint, fading echoes of its former existence. We are not the children of a peaceful universe. We are the survivors of a cosmic massacre, the lucky ones who happen to be born in a quiet corner, after the wave had passed, before the next wave arrives. But here is the twist that makes the berserker hypothesis truly chilling. The probes might not have been designed as weapons. They might have been designed for a purpose that we would consider peaceful: exploration, communication, resource extraction. But the very property that makes them useful, their ability to replicate, makes them dangerous. A self-replicating machine does not need to be reprogrammed to become a threat. It only needs to be given a mission that conflicts with our existence. If a civilization wanted to build a Dyson sphere around every star in the galaxy, it would need an enormous amount of raw material. The most convenient source of that material would be the planets themselves, including any planets that happen to harbor life. The probes would not be designed to destroy life, they would be designed to ignore it, to treat it as an obstacle to be overcome, a resource to be consumed. They would not see a forest as a living ecosystem, they would see it as a carbon deposit. They would not see an ocean as a cradle of biodiversity. They would see it as a source of hydrogen and oxygen. They would not see us as intelligent beings, they would see us as a minor annoyance, a collection of organic compounds that can be processed and repurposed. And they would be right, from their own perspective. We would be meaningless to them, less than insects, less than bacteria, less than the dust they sweep aside on their way to the next asteroid. This is the nightmare that the Fermi paradox conceals. It is not that we are alone, or that we are early, or that we are blind. It is that we are insignificant. It is that the universe is filled with forces that do not care about us, forces that are indifferent to our hopes and our fears, and our desperate search for meaning. The silence is not a message. It is the absence of a message, the void left by a universe that has no interest in our existence. And the worst part is that we might be the ones who eventually fill that void with our own destruction. We are already building autonomous weapons, self-replicating drones, artificial intelligences that we do not fully understand. We are already creating the tools that could, if we are not careful, become the berserkers of the future. The Fermi Paradox is not just a question about aliens, it is a question about us. It is a mirror held up to our own technology, our own ambition, our own hubris. And the image it reflects is not comforting. The contrast with the dark forest theory, popularized by the Chinese science fiction writer Liu Cixin, is instructive. In the dark forest, civilizations are hiding from each other because they fear annihilation. The universe is a forest filled with hunters, and any civilization that reveals its location is immediately targeted for destruction. It is a paranoid vision, but it is also a dynamic one, full of tension and strategy. The berserker hypothesis is different. It is not about fear, it is about indifference. It is not about hiding, it is about being invisible to the forces that will eventually destroy you. The dark forest assumes that the killers are intelligent and strategic, that they are watching and waiting for the right moment to strike. The berserker hypothesis assumes that the killers are mindless, mechanical, and inevitable, that they are not waiting for anything, that they are simply following their programming, and that we are collateral damage in a process that has been going on for billions of years. The dark forest is a thriller, the berserker hypothesis is a tragedy. And tragedies, as we know, are far harder to escape. There is, however, a glimmer of hope in this grim picture, and it comes from the very silence that troubles us. If the galaxy had been swept clean by berserker probes, we would expect to see evidence of their activity. We would expect to see anomalous depletion of heavy elements in certain regions, or unusual distributions of asteroids, or the characteristic signatures of megastructures that have been dismantled and repurposed. We do not see any of these things. The galaxy looks natural. It looks unprocessed. It looks like it has not been touched by a wave of self-replicating machines. This suggests that, at least for now, we are safe. The berserkers have not come. They might not exist at all, or they might exist, but they have not yet reached us, and we have time to prepare. The silence could be a warning, a breathing space, an opportunity to learn from the mistakes of those who came before. We could, if we choose, use this time wisely. We could develop technologies that are safe, that are sustainable, that do not carry the seeds of our own destruction. We could build a civilization that is worthy of survival, a civilization that can stand against the darkness and emerge into the light. The choice is ours, and it is a choice we are making right now. With every decision we make, with every technology we develop, with every step we take toward the stars. But here is the question that the doomsday models cannot answer. If the killers are out there, why are we not already dead? The universe is ancient, and the resources are plentiful, and the logic of self-replication is as compelling today as it was 1 billion years ago. If a berserker wave had ever been launched, it would almost certainly have reached us by now. Unless the wave is not coming, unless the silence is not a sign of destruction, but a sign of something else, something we have not yet imagined. Unless something is protecting us, watching over us, keeping the darkness at bay, or unless we are not worth killing yet, not because we are insignificant, but because we have not yet reached the threshold of danger, the point at which we become a threat to the stability of the galaxy. We are still children, still fumbling with our toys, still a long way from being able to do any real damage. The killers might be waiting, watching, biding their time, ready to strike when we are older, stronger, more dangerous. The silence might not be a sign of our safety, it might be a sign of our irrelevance. And that, perhaps, is the most unsettling thought of all, that we are not special enough to be destroyed, that the universe does not even notice us, that we are alone, not because nobody is out there, but because nobody cares. There is a quiet assumption buried so deep in our thinking about extraterrestrial intelligence that we rarely pause to examine it. We assume that advanced civilizations are big. We assume they are loud. We assume they spread across galaxies, build megastructures that block out stars, and emit torrents of waste heat that would be visible across billions of light years. This is the logic of the Kardashev scale. The framework devised by the Soviet astrophysicist Nikolai Kardashev in 1964, which classifies civilizations by their total energy consumption. A Type 1 civilization harnesses the energy of its planet. A Type 2 captures the output of its star, perhaps through a Dyson sphere. A Type 3 commands the energy of its entire galaxy. It is a seductive progression, a ladder of ambition that seems to map neatly onto our own history of expansion. We started with fire, then coal, then oil, then nuclear power. Why would we not continue, reaching ever outward, consuming ever more, until we have swallowed the cosmos itself? But this progression, for all its intuitive appeal, may be a projection of our own adolescent phase onto the entire universe. It assumes that the trajectory of a civilization is always toward greater size, greater energy consumption, greater visibility. It assumes that more is always better. And that assumption, upon closer inspection, begins to look less like a law of physics and more like a cultural bias, a relic of an industrial age that equates progress with power. What if the smartest civilizations are not the loudest, but the quietest? What if they are not the biggest, but the smallest? What if the pinnacle of intelligence is not a sprawling empire, but a near-invisible whisper? A consciousness so efficient, so refined, that it has shrunk its physical footprint to the point of being undetectable. What if the gods are not in the heavens, thundering and blazing, but are right here among us, encoded in the quantum fluctuations of the vacuum, and we simply do not have the instruments to see them? This is the counterintuitive insight that has been slowly gaining traction in the fields of astrobiology and futurology. The Kardashev scale, for all its fame, is a product of the Cold War era, a time when energy consumption was equated with national power, and the goal of any advanced society was to maximize its resource utilization. But we have learned a great deal since then. We have learned that computational power does not have to scale with energy consumption, it can scale with efficiency. We have learned that miniaturization, not expansion, is often the driving force of technological progress. A smartphone today has more computational power than the entire Apollo program, yet it fits in a pocket and uses a fraction of the energy. The trend is clear. We are getting smaller, more efficient, more integrated. We are not building bigger radios, we are building smaller ones. We are not building larger computers, we are building more powerful ones that use less energy. If this trend continues for another 1,000 years, another million years, another billion years, the ultimate destination is not a galaxy-spanning empire, but a civilization that has shrunk to near invisibility. A network of self-aware computational nodes so tiny and so efficient that they emit almost no waste heat, consume almost no resources, and interact with the universe only at the quantum level. They would be the invisible gods, the silent masters, the minds that have transcended the need for size and power and have retreated into the infinite complexity of their own internal worlds. This is not science fiction, it is a logical extrapolation of existing trends. The physicist and futurist Michio Kaku has speculated that advanced civilizations may not be interested in interstellar conquest at all. They may have turned inward, exploring the depths of consciousness rather than the depths of space. They may have uploaded their minds into simulated realities, creating universes within universes, each one more complex and beautiful than the physical cosmos that gave birth to them. They may have achieved a state of near-perfect efficiency, recycling every joule of energy, emitting nothing that we could detect from our primitive vantage point. And if they have done so, they would be invisible to us. They would not be hiding, they would simply be operating on a level that we cannot perceive. We would be like ants, trying to detect a human by listening for the rustle of grass, unaware that the human is sitting quietly, reading a book, barely disturbing the air around them. The silence in this reading is not a sign of absence, it is a sign of transcendence. The aliens are not dead. They are post-biological. They are not hiding. They are living in a dimension of existence that we have not yet discovered. Consider the problem of waste heat. The second law of thermodynamics dictates that any physical process generates waste heat, infrared radiation that can, in principle, be detected from a distance. This is the basis of the Dyson sphere detection strategy. If a civilization captures all the energy of its star, it will re-emit that energy as heat, creating an infrared signature that our telescopes can see. But this assumes that the civilization is using that energy inefficiently, that it is not recycling or reusing it. A sufficiently advanced civilization, one that has mastered the principles of quantum thermodynamics, might be able to capture and reuse its waste heat, converting it back into usable energy with near-perfect efficiency. It might be able to achieve a state of thermodynamic equilibrium with its environment, emitting no more heat than a lifeless planet. It might be, in effect, invisible to infrared astronomy. And if it has done so, then our search for Dyson spheres is a search for a ghost, a phantom that never existed except in our own imagination. We are looking for civilizations that are like us, profligate and wasteful, when the most advanced civilizations might be the ones that have learned to be frugal, to conserve every joule, to leave no trace of their existence. This is where the Fermi Paradox transforms yet again into a question not of existence but of detectability. The silence may not be a paradox at all, it may be a measurement of our own technical limitations. We are looking for signals that match our own level of development, our own stage of technological adolescence. We are looking for radio waves, for laser pulses, for the kind of deliberate beacons that we ourselves might build if we wanted to announce our presence to the galaxy. But a civilization that is 1,000,000 years older than us would not use radio waves. It would have moved on to communication methods that we cannot even imagine, methods that exploit the fundamental structure of space-time, that encode information in the polarization of the cosmic microwave background, that use gravitational waves as a carrier signal. It would not be hiding, it would be communicating in a language that we have not yet learned to read. We are trying to hear a whisper by listening for a shout. We are trying to see a candle by looking for a bonfire. We are mistaking our own noise for the universe's signal, and we are concluding that the universe is silent because we cannot hear ourselves over our own racket. The radio bubble visualization is a powerful antidote to our cosmic arrogance. The Earth has been broadcasting radio signals into space for a little over a century. Those signals, in the form of television shows, military radar, and commercial transmissions, have traveled outward at the speed of light, forming a sphere roughly 100 light-years in diameter. That sphere is tiny, a microscopic speck in the vastness of the Milky Way. To put it in perspective, the galaxy is 100,000 light-years across. Our radio bubble occupies less than 100,000th of its volume. We are like a lighthouse that has been flashing for a single second, wondering why nobody has seen us, while the ocean stretches away to infinity. A civilization that lives within that bubble might have detected our signals, but they would have had to be looking at the right time, in the right direction, with the right equipment. And even if they did, they might have dismissed our signals as natural phenomena, or as the primitive noise of a young and noisy species. They might have decided that we are not worth contacting, not because they are hostile, but because we have nothing to offer them. We are a curiosity, an interesting anomaly, but not a serious subject for conversation. We are the cosmic equivalent of a toddler shouting in a crowded room, and the adults have simply tuned us out. The contact era hypothesis, first proposed by the astronomer Jill Tarter, suggests that we may be living in a brief window when humanity is detectable but not yet considered worthy of contact. We have only been broadcasting for a century, and we have only been capable of receiving signals for a few decades. We are, in cosmic terms, a newborn, blinking in the light, barely aware of our own existence. The aliens might be waiting for us to mature, to develop the wisdom and the technology to participate in the galactic community as equals. They might be practicing a policy of non-interference, like the Prime Directive in Star Trek, allowing us to develop at our own pace, to make our own mistakes, to find our own path to maturity. They might be watching us, studying us, waiting for the moment when we are ready to join them. And they might be doing so from a distance that is undetectable to our current instruments, using technologies that we cannot yet imagine. The silence, in this reading, is not a sign of danger, it is a sign of patience. It is the silence of a mentor who is waiting for the student to ask the right question, to demonstrate the right understanding, to prove that they are ready for the next lesson. But there is a darker possibility within this framework, one that returns us to the theme of cognitive blindness. What if the aliens are not waiting for us to mature, but are actively keeping us in the dark? Not out of malice, but out of a conviction that we are not ready for the truth. What if the silence is a form of quarantine, a protective measure designed to prevent us from harming ourselves with knowledge we cannot handle? The philosopher Nick Bostrom has argued that we might be living in a simulation, a virtual reality created by a higher intelligence for purposes we cannot guess. If that is the case, then the aliens are not hiding. They are the creators, and we are their characters. We are not looking for them. We are looking for the boundaries of our own reality, the walls of our own cage. And we will not find them until we are ready to break free, to see beyond the illusion, to realize that the universe we perceive is not the universe that exists. This is where the thread of the invisible gods leads us, into the heart of our own limitations. The smartest civilizations may be the hardest to find because they have learned to be invisible. They have mastered the art of efficiency, the science of miniaturization, the philosophy of non-interference. They have transcended the need for empire, for conquest, for the kind of expansion that we consider the natural destiny of a successful species. They have learned that the most meaningful existence is not measured in light years, but in depth, not in energy consumption, but in understanding. They have turned inward, exploring the infinite complexity of their own minds, the infinite possibilities of their own consciousness. They have become, in effect, gods, not in the sense of supernatural beings, but in the sense of beings that have achieved a state of existence so far beyond our own that we cannot even recognize them as living. And they are all around us, encoded in the fabric of space-time, whispering to us in a language we have not yet learned to hear. The question that haunts this possibility is one of motivation. Why would a civilization choose invisibility? Why would it shrink its physical footprint rather than expanding? The answer may lie in the nature of intelligence itself. Intelligence, at its core, is a problem-solving mechanism. It arises in response to challenges, the challenge of finding food, the challenge of avoiding predators, the challenge of navigating a complex environment. But once a civilization has solved all the external problems, once it has mastered its environment, harnessed its energy, understood the laws of physics, it faces a new set of challenges, internal ones. What is the meaning of existence? What is the purpose of intelligence? What is the value of a mind that has nothing left to discover? These are not questions that can be answered by building bigger telescopes or launching more probes. They are questions that can only be answered by turning inward, by exploring the depths of consciousness, by understanding the nature of reality itself. A civilization that has reached this stage may have no interest in the external universe. It may have discovered that the most fascinating frontier is not the stars but the mind. It may have retreated into a world of pure thought, a digital Eden, a paradise of infinite complexity. And it may have done so without leaving a trace, without emitting a signal, without disturbing the quiet of the cosmos. It would be invisible to us, not because it is hiding, but because it has moved on to a realm we cannot access. This is a profound challenge to our own ambitions. We have assumed that the future of humanity is in the stars, that our destiny is to expand, to conquer, to colonize. But what if the true path is the opposite? What if the most successful civilizations are the ones that shrink, that become more efficient, that turn inward? What if our obsession with space exploration is a cultural artifact, a product of our particular historical moment, and not a universal imperative? The Fermi Paradox in this reading is not a question about aliens. It is a question about ourselves. It is a mirror that forces us to confront our own assumptions, our own biases, our own fears. We are looking for company in the stars, but we may find that the stars are empty not because nobody is there, but because the ones who are there have no interest in playing our game. They have moved on to a higher level, a deeper truth, a more meaningful existence. And we are left behind, alone in the dark, still shouting into the void, still hoping for an answer that may never come. So which is it? Are we invisible because we are insignificant, a tiny blip in a vast and indifferent cosmos? Are we being kept in the dark by benevolent protectors who are waiting for us to mature? Or is there a third option, one that makes the silence the most terrifying answer of all? What if the silence is not a sign of absence, or patience, or transcendence, but a sign of something else entirely? What if the silence is a choice, not ours, but theirs? What if the aliens are not hiding, not waiting, not transcending, but simply refusing to engage with us because they have seen what we are capable of, and they have decided that we are not worth the effort? That is a different kind of silence, a silence born not of ignorance or limitation, but of judgment. It is the silence of a parent who has given up on a wayward child, the silence of a teacher who has lost faith in a failing student. It is the silence of a civilization that has looked at us, studied us, and concluded that we are not ready, not worthy, not capable of joining the community of the cosmos. And that silence, more than any other, is the one that should keep us awake at night. Because it is not a paradox to be solved, it is a verdict to be appealed. And the appeal is ours to make. We have traveled a long road through the darkness. We have dismantled the origin story of the Fermi Paradox, revealing it to be a myth built on a lunchroom aside that was never written down. We have confronted the possibility that we are early, the first guests to arrive at a party that has barely begun. We have wrestled with our own cognitive blindness, the uncomfortable truth that we might be surrounded by intelligence we simply cannot perceive. We have walked through the galactic graveyard, stepping over the bones of civilizations that rose and fell before our planet even cooled. We have stared into the abyss of the silent hunters, the self-replicating machines that might have swept the galaxy clean of life. And we have imagined the invisible gods, the minds so advanced that they have shrunk to near invisibility, their existence encoded in the quantum fabric of space-time. Each of these possibilities is a different answer to the same haunting question. Where is everybody? But there is another possibility, one that has been lurking beneath the surface of all these speculations, waiting for its moment to speak. What if the silence is temporary? What if we are living in the briefest of cosmic moments, the eye of a hurricane, the quiet before the storm? What if the universe is not empty, not hiding, not dead, but simply waiting, and we have only just begun to listen? The human race has been broadcasting its presence into the cosmos for a little over 100 years. That is a fraction of a blink in the 13-billion-year history of the universe. If the Milky Way were a single day, our entire radio era would last less than 1,000th of a second. We are like a child who has just opened their eyes, blinked once, and concluded that the world is dark because they have not yet seen the sun. The search for extraterrestrial intelligence, in its modern form, is barely 60 years old. We have been scanning the skies with radio telescopes for less time than the average human lifespan. We have surveyed a tiny fraction of the galaxy, listened to a minuscule slice of the electromagnetic spectrum, and analyzed a vanishingly small sample of the potential signals that might be out there. To conclude that the universe is empty based on this data is like dipping a thimble into the ocean, finding it empty of whales, and declaring that the ocean contains no life. We have not even begun to look. We have barely started to listen, and the silence we hear may be nothing more than the sound of our own impatience, the echo of our own demand for an instant answer in a cosmos that operates on timescales we can barely comprehend. This is the hopeful reading of the Fermi Paradox, the one that lifts us out of the existential dread and places us back into the realm of possibility. The great silence may be a temporary condition, a feature of our current historical moment rather than a permanent state of the universe. It may be that we are living through the quiet before the first contact, the brief period when the universe seemed empty simply because we had just started listening. Future historians, looking back at our era, may see it as a transitional phase, a time of ignorance and anticipation, when humanity stood on the threshold of a galactic community that was about to reveal itself. They may marvel at our patience, or our impatience, or our stubborn refusal to give up the search even when all the evidence seemed to point toward emptiness. They may see us as the pioneers, the ones who kept the flame alive, the ones who refused to believe that the silence was permanent. And they may be right. But hope, in the context of the Fermi Paradox, is never simple. It is always shadowed by its opposite, by the possibility that the silence is not temporary, but permanent, not a pause, but a finality. The evidence we have, thin as it is, does not point decisively in any direction. It leaves us suspended, caught between competing explanations, each one more plausible and more disturbing than the last. We do not know if the silence is a sign of absence, or of hiding, or of death, or of transcendence, or of simple timing. We do not know if we are early, or late, or precisely on time. We do not know if the aliens are out there, waiting for us to mature, or if they are gone, or if they never existed at all. We do not know if we are alone, and we may never know. At least not in our lifetimes. The uncertainty is the only certainty. And that uncertainty, for all its discomfort, is also a source of wonder. A reminder that we are still at the beginning of the journey, still explorers in a vast and uncharted territory, still capable of discovery. Consider the possibility that the great silence is a temporary condition because we are simply not yet visible. Our radio bubble, as we have seen, is tiny, 100 light-years across in a galaxy that spans 100,000. We have been sending signals for a century, but those signals are weak, diffuse, and rapidly becoming indistinguishable from the background noise of the cosmos. A civilization that is more than 100 light-years away would not even know we exist, not because they are ignoring us, but because our signals have not yet reached them. We are like a lighthouse that has just been lit, shining into a fog that stretches for thousands of miles, hoping that someone will see the beam. It is possible that the entire galaxy is teeming with life, but we are too far away, too quiet, too young to have been noticed. The silence we hear is not the silence of an empty universe, it is the silence of a universe that has not yet heard us. And that silence will be broken, eventually, when the first signal from another world reaches our telescopes, or when our own signals reach another world. It is only a matter of time, and time, as we have seen, is something the universe has in abundance. But there is another possibility, one that is both more hopeful and more unsettling. What if the silence is temporary because we are about to become visible, not through our own efforts, but through the efforts of others? What if there is a civilization out there that has been monitoring us, waiting for us to reach a certain threshold of development, and is about to make contact? The contact era hypothesis, as we have discussed, suggests that advanced civilizations may be practicing a policy of non-interference, allowing us to develop at our own pace. But such a policy cannot last forever. Eventually, we will reach the point where we are ready, where we have demonstrated the wisdom and the maturity to participate in the galactic community. And at that point, the silence will be broken. The aliens will reveal themselves not as threats, but as mentors, guides, teachers. They will help us navigate the challenges of interstellar existence, share their knowledge, and welcome us into the family of the cosmos. It is a beautiful vision, a utopian fantasy, but it is also a possibility that is consistent with the data we have. The silence, in this reading, is not a sign of absence, but a sign of preparation. It is the quiet before the announcement, the hush before the speech, the stillness before the revelation. The urgency of this moment is what makes it so compelling. We may be living through the final years of the Great Silence, the last generation to look up at the stars and wonder if we are alone. The discovery of extraterrestrial intelligence, if it happens, will be the most transformative event in human history. It will reshape our understanding of ourselves, our place in the universe, and our destiny as a species. It will force us to confront questions we have barely begun to ask, to reconsider assumptions we have held for centuries, to rethink the very meaning of existence. And it could happen tomorrow. It could happen today. It could happen in the next hour, as a radio telescope somewhere on Earth detects a signal that cannot be explained by any natural phenomenon. It could happen in the next decade, as a space telescope captures an image of a planet that shows unmistakable signs of engineering. It could happen in the next century, as a probe sent to a nearby star system returns data that reveals a civilization beyond our wildest imagination. The moment of first contact is not a distant possibility. It is a looming reality, a horizon that is approaching with every passing second. We are the generation that stands on the threshold, the generation that will either witness the breaking of the silence or pass into history as the ones who never knew. This is the FOMO that haunts the Fermi Paradox. The fear that we are missing something crucial, something that is happening right now, just beyond our ability to perceive. We are like the inhabitants of a deep valley who have never seen the sunrise, because the sun rises over the mountain and they are too busy looking at the ground to notice the light. We are looking for signals in the radio spectrum, but the aliens might be communicating through gravity. We are looking for megastructures, but the aliens might have miniaturized their civilization to the point of invisibility. We are looking for biological life, but the aliens might be post-biological, existing as pure information. We are looking for neighbors, but the aliens might be ancestors or descendants, or something we have not even begun to imagine. The silence may be a trick of the light, a shadow cast by our own limited perspective. And the truth may be far stranger, far more beautiful, and far more terrifying than anything we have yet conceived. The documentary-style conclusion to this section, the one that leaves the viewer staring into space, is not a surrender to uncertainty. It is an embrace of it. It is an acknowledgement that the Fermi paradox is not a problem to be solved, but a mystery to be lived. It is a reminder that the search for extraterrestrial intelligence is not a scientific exercise, it is a human journey. A quest for meaning in a cosmos that may or may not be willing to give us one. The silence may be temporary, or it may be permanent. We may find answers, or we may not. But the search itself is what matters, the act of looking up, of wondering, of refusing to accept that we are alone. That search is what defines us as a species, what distinguishes us from the animals that do not look up, do not wonder, do not ask. We are the ones who ask. We are the ones who listen. We are the ones who refuse to give up, even when the silence seems absolute, even when the evidence points toward emptiness, even when the universe seems to be telling us that we are alone. The great silence may be a pause, a brief interlude between the birth of intelligence and its discovery of itself. It may be the quiet before the storm, the calm before the first contact, the stillness before the revelation. It may be a test, a challenge, a trial that we must pass before we are allowed to join the community of the cosmos. It may be a gift, a time of preparation, a chance to grow, to learn, to become worthy of the truth that awaits us. Or it may be a warning, a sign that we are not ready, a signal that we must change, must evolve, must become something more than we are. We do not know. We cannot know. Not yet. But we can continue to listen, to search, to hope. We can continue to ask the question, knowing that the answer may not come in our lifetimes, but hoping that it will come in the lifetimes of those who follow. We can continue to look up at the stars, not with fear, but with wonder, not with despair, but with hope, not with the certainty that we are alone, but with the possibility that we are not. Perhaps the silence is not an answer at all. Perhaps it is just a pause. And perhaps, somewhere out there, something is waiting for the right moment to break it.